At the dawn of the 20th century, humanity looked at the sky with wonder, but also with doubt, because for thousands of years, flight belonged only to birds and imagination. Yet in 1903, on a windy stretch of sand in North Carolina, the determined minds of the Wright brothers proved that controlled, powered flight was not a fantasy, but a mechanical reality. And although their first powered aircraft remained airborne for only seconds, that fragile machine ignited a revolution that would reshape transportation, economics, warfare, diplomacy, and culture across the entire planet. And from that moment forward, the sky was no longer an unreachable ceiling, but a new frontier waiting to be mapped, engineered, and mastered. Early aviation was defined by experimentation, risk, and relentless curiosity as pioneers tested wing shapes, propeller angles, and engine configurations, often learning through failure and redesign rather than instant success, because true innovation rarely arrives fully formed, but instead evolves through persistence, calculation, and courage. As the years progressed, aviation moved from experimental demonstrations to practical applications, particularly during World War I, when military necessity accelerated aircraft development, forcing engineers to design faster engines, stronger airframes, and more stable control systems. And when the war ended, the knowledge gained during those intense years did not disappear, but flowed directly into civilian aviation, opening the door for commercial air travel and global air routes. During the interwar period, aviation captured public imagination with air races, record-breaking long-distance flights, and the birth of passenger airlines. And among those early giants stood Pan American World Airways, which pioneered international connections and symbolized prestige, modernity, and ambition as flying boats crossed oceans and navigators relied on celestial calculations to guide aircraft across vast stretches of water. Airports during this era were modest fields compared to today's massive terminals, yet they represented gateways to opportunity and progress as governments recognized aviation not only as transportation, but as strategic infrastructure capable of connecting cities, nations, and continents. Then came the transformative era of World War II, when aviation technology advanced at extraordinary speed, producing pressurized cabins, radar navigation, long-range bombers, and powerful piston engines. And after the war, surplus aircraft manufacturing expertise and trained pilots created the foundation for explosive commercial growth in the late 1940s and 1950s. The true revolution, however, arrived with the jet age, as companies like Boeing introduced commercial jetliners that replaced propellers with turbojet engines, dramatically increasing speed, altitude, and passenger comfort, while reshaping global expectations of travel time and accessibility. And competitors such as McDonnell Douglas further intensified innovation, creating a dynamic competitive environment that pushed technological boundaries year after year. Airlines expanded rapidly, and among them, American Airlines grew into one of the most influential carriers in the United States, building sophisticated hub networks, optimizing fleet strategies, and investing heavily in safety, training, and customer experience, while competing closely with rivals like Delta Airlines and United Airlines, whose own expansions fueled a golden era of commercial competition and route development. Behind each scheduled departure stands an invisible orchestra of professionals, including dispatchers calculating fuel loads, meteorologists analyzing upper-level winds, maintenance engineers performing multi-layered inspections, and air traffic controllers sequencing departures with mathematical precision to maintain safe separation in increasingly crowded skies. The introduction of wide-body aircraft transformed international travel into a mass experience, enabling millions rather than thousands to cross oceans annually, while computerized reservation systems revolutionized ticket distribution and revenue management, creating data-driven airlines capable of forecasting demand and adjusting pricing dynamically. Modern cockpits evolved from analog instrument panels into digital glass environments where integrated avionics provide real-time data about altitude, speed, weather, terrain, and system performance, and fly-by-wire control systems enhance stability by translating pilot inputs into computer-mediated adjustments that optimize safety and efficiency. Across the Atlantic, the rise of Airbus introduced fierce competition that drove both manufacturers toward lighter composite materials, more fuel-efficient engines, and passenger-focused cabin innovations, such as improved pressurization, humidity control, and quieter interiors. Deregulation reshaped the American airline industry, lowering fares and increasing competition, while forcing carriers to become operationally lean and strategically agile. And through economic downturns, fuel crises, and shifting consumer expectations, aviation demonstrated resilience by continuously adapting through technology partnerships and restructuring. Safety culture strengthened with advanced training simulators, black box data analysis, predictive maintenance algorithms, and collaborative oversight between regulators, manufacturers, and airlines, collectively making commercial aviation one of the safest transportation systems ever created. Today, innovation continues at remarkable pace as engineers explore sustainable aviation fuels, hybrid electric propulsion, hydrogen concepts, and aerodynamic refinements designed to reduce environmental impact without compromising performance, while aerospace visionaries, including SpaceX, inspire a broader conversation about reusable launch systems and the evolving boundary between atmospheric flight and space travel. Airports transform into smart ecosystems, integrating biometric boarding, automated baggage systems, AI-driven traffic flow management, and energy-efficient infrastructure designed for a future where sustainability and connectivity must coexist. Yet beyond the data, algorithms, and composite materials, the essence of aviation remains deeply human because every takeoff represents trust, every cruise altitude represents collaboration, and every landing represents precision achieved through teamwork and discipline. Passengers looking through cabin windows witness not just clouds and landscapes, but the culmination of more than a century of accumulated knowledge, innovation, and ambition, stretching back to the wind-swept dunes where the Wright brothers first lifted from the earth. Aviation connects families, powers global trade, supports humanitarian missions, enables scientific exploration, and reinforces cultural exchange on a planetary scale, proving that flight is not merely a technical achievement, but a transformative force shaping how humanity experiences distance, opportunity, and possibility. As research pushes toward autonomous systems, quieter engines, and even a revival of supersonic passenger travel, the next chapters of aviation promise shorter travel times, cleaner propulsion, and smarter skies, where aircraft communicate seamlessly to optimize routes and reduce congestion. Still, no matter how advanced systems become, the human element remains central because engineers must imagine, pilots must train, technicians must maintain, and passengers must continue to believe in the power of flight. And as long as curiosity drives innovation and ambition fuels progress, the story of American aviation will continue to evolve, climbing higher, reaching farther, and redefining what is possible above the horizon, where the sky is not the limit, but simply another journey waiting to unfold. Continuing the narrative, expanding deeper into technology, business strategy, engineering psychology, and future projections of aviation and air transportation at a much more detailed level designed for long-form text-to-speech content that can run for hours without interruption. After the foundation laid by early pioneers, aviation entered an era where engineering precision became the dominant factor in performance and safety because modern aircraft are not built through intuition alone, but through complex computational simulations, structural stress testing, wind tunnel experiments, and material science research that evaluates how aluminum alloys, titanium components, and composite fibers behave under extreme pressure, temperature variation, and aerodynamic load. Engineers analyze lift through advanced fluid dynamics equations that measure how air flows over curved wing surfaces, creating pressure differences that generate upward force. And these calculations are continuously refined using supercomputers capable of simulating millions of airflow interactions per second, allowing designers to reduce drag, improve fuel efficiency, and enhance stability even before the first physical prototype is manufactured. In commercial aviation, one of the most critical systems is propulsion, and jet engine technology has evolved dramatically from early turbojets to high bypass ratio turbofan engines that achieve greater thrust with lower noise and improved fuel consumption, because modern engines compress incoming air, mix it with precisely measured fuel, ignite it in controlled combustion chambers, and channel exhaust through